Hi! In this lecture, we're going to talk about if-then statements and how to prove them. So let's begin with the basic if-then statement. If it is raining, then Mary has an umbrella. This statement has been clearly divided into two clauses. The first one is if it is raining. This is what we would call our hypothesis, and we typically denote that by the letter P. So in mathematics, the word hypothesis might mean something different than in other scientific contexts. In an experiment, a hypothesis might be a conjecture, something that you think is true, which you are going to test. Whereas in mathematics, the word hypothesis is not something that we guess is true and that we're examining. Rather, a hypothesis is an assumption that we are making. So in this statement, I'm saying if it rains, assume it's raining, then Mary has an umbrella. Mary has an umbrella is what you would call the conclusion, and it's frequently denoted by Q. Q is the conclusion that follows, so Q must happen if P happens. You could never have P without having Q. We denote this a few different ways, so here are just the basic ways. If P, then Q, and a more shorthand way, we write P implies Q. And then the word implies is often replaced with a double arrow, so we'll say P double arrow Q, meaning P implies Q. And a little rare for an if-then statement, you might see P only if Q, which emphasizes the fact that P can't happen unless Q also happens, because P implies Q. Moving on, there are two important constructions that we can build off of this kind of if-then statement. The first one is logically equivalent to the original statement. This is called the contrapositive. What the contrapositive does is essentially reverse the roles of which of the two clauses you consider first. And what we do to form the contrapositive is we say, if not Q, then not P. This kind of tilde symbol I'm writing here is what we would use to denote not. In other contexts, you might see more of like an angular kind of bar. So not Q implies not P is logically equivalent because, again, you couldn't have Q unless you also have P. In this particular context, the contrapositive of our given statement would be not Mary has an umbrella implies it's not raining. Or better put, if Mary doesn't have an umbrella, then it's not raining. Because, going back to the original, if it were raining, then she would have an umbrella. A different kind of construction, which is not logically equivalent to the original statement, although it could be, so the second construction has to be evaluated every time you look at it. But the second kind of construction is called the converse. And what we do with the converse is we just completely switch the roles of P and Q. So instead of P implies Q, the converse is Q implies P. Here that would be, if Mary has an umbrella, then it is raining. Whether or not the converse is true here really depends on Mary. In this context, perhaps Mary is really good at understanding the weather, and so you know if you see her with an umbrella, it's because she knows it's raining. And this could be true. Or the converse might be false. Perhaps Mary always has an umbrella, even on a sunny day. So the converse may or may not be true compared to the original statement, and you would have to evaluate each mathematical converse on a case-by-case basis. If, however, the converse for a particular statement is true, then P implies Q, and Q implies P. In mathematics, this is what we call an if and only if statement. So you can say P if and only if Q. If you focus on the if part, P if Q is really another way of saying if Q then P. And P only if Q, going back to the top, is like P implies Q. Okay, so P if and only if Q means that P and Q, these two clauses go hand in hand. They are either both true or both false. Often, if and only if is abbreviated IFF, if. And I frequently use the double arrow notation. This is common too, so P implies Q and Q implies P in this setting would be P left arrow and right arrow Q. And we could read that as P if and only if Q. For Mary, that's like saying If it's raining, Mary has an umbrella, and if Mary has an umbrella, then it's raining. So it rains if and only if Mary has an umbrella.